Hello viewers, hope you all are fine. So I'm here to proceed with the same topic, algebraic identities. We have seen first 5 identities. This is a topic from chapter number 2, polynomials of grade 9. So today in this video we'll see the next 3 identities related to that topic, and before that let's solve a few more questions related to first 5 identities. We have seen few of the questions in the last video. These are next questions from the last exercise. So question number 1 is asking me to expand this without using the actual multiplication. How we will do? So we will make use of that identities. See how. This 103 can be written as 100 plus 3. That's fine. Now this 107 can be written as 100 plus 7. So this bracket is giving us multiplication. So nothing has changed. 100 plus 3 is 103. 100 plus 7 is 107. We are multiplying these two. So this will be equals to. Now this is of the form what? Let me write that identity. This is similar to, every time you have to give reason why you are making use of any identity. So this is similar to x plus a, x plus b. X is what? 100 here. So I'll write x is equals to 100 here. A is equals to 3 and b is equals to 7. So what was the expansion? We know that this was the expansion as I have taught you in the last video. This plus ab. So this is the actual identity that we are making use of. So this can be written as, this is the result, this side we have already. So I'll put the values here for x and ab. So 100 square I'm putting here plus a plus b means 3 plus 7 outside x. X is what? 100 here plus a into b. A into b is what? 3 into 7. Fine. So this is equals to 1, 2, 3, 4. 4 zeros. 10 into 100 basically plus 21. So this is equals to 1000. This is plus 21. So we can sum up all these. This is 10,000. This is 1000 and last one is 21. So I'm getting 21011. This 11021. So this is my answer. This is how we can actually get the answer without multiplying these two. This means that we have to make use of the suitable identity here. So this one is the suitable identity for this question. Let's see any of these questions to have more clarity. This question, 95 into 96. Solve this without using actual multiplication. So I can write this as 100 minus 5 and 100 minus 4. Yes, 100 minus 5 is 95, 100 minus 4 is 96. So again this is identical to x plus a, x plus b. Only this was the identity we have seen in the chapter where plus was there. There was no such identity that was having minus. So I will try to convert this into plus first. So let me expand this. The result was, again I am writing, this was the result. So this can be written as x plus of, 100 plus of minus 5. Fine. So this is plus here now. 100 plus of minus 4. Yes, we can write like this. Why? Because this plus minus is minus again. So now what I am having on comparing, I am getting x is 100, a is equals to minus 5 and b is equals to minus 4. You can write on comparing, we are getting these. Now put the values in the identity. So this will be equals to, this is the left side, right hand side we will get by putting the values. 100 square plus a plus b. What is my a? This is my a plus b. Plus b. Close the bracket. This is x outside. X is 100 again. Plus of ab. Plus of ab. What is a? Minus 5. But what is b? Minus 4. So this is equals to, again, 10,000. This is, now let me write this. This is minus 5. Plus minus is minus. Minus 4 outside 100. And this is what? Plus is fine here. Minus minus is plus. So plus plus is plus. 5 4s are 20. Plus 20 I'll get here. So this is equals to 10,000 plus. Minus minus is plus. We'll plus these two numbers. So I'm getting 9. And sign of what? I will get sign of bigger one. So minus 5 is bigger value. So sign in front of 5 is what? Minus. So I'm getting minus 9 with 100 plus 20. So this is equals to, again, 10,000. Plus minus is minus. Now we can multiply this 9 with 100. So I am getting 900 plus 20. So we have these three values. We can easily solve and get our answer. So you can get your answer by solving this. This was the procedure how we can change these minus sign into plus and make use of this identity when we are having minus in both the brackets, or even in the single bracket. If we are getting minus, we can make use of this plus sign to get the minus in actual, and we can apply this identity. Let's move to the next question. 7b minus c. 3a minus 7b minus c. I have to expand this using suitable identity. So we have seen first 5 identities. This is somewhere similar to x plus y plus z whole square. So what was the result? It was x square plus y square plus z square plus 2xy plus 2yz plus 2zx. So this was the result for this identity. Let's see how to solve this question. Again, we'll make this minus as plus. So I can write it as 3a plus of minus 7b plus of minus c. Now on comparing these two, what I am getting? I am getting x is equals to 3a, y is equals to minus 7b, and z is equals to minus c. Just by putting these values here, I'll get my answer. So 3a whole square. What is the first term? X square. Next is y square. Y is minus 7b whole square. Next is z square. Z is minus c whole square. Plus 2xy. Let me write here. Plus 2. What is x? X and y. 3a and minus 7b. Plus 2 of yz. Minus 7b and minus c. Plus 2 of xz. xz or zx. What is x here? 3a, and what is z? Minus c. So we can solve this. So my answer is 9a square, 7 sevens are 49, minus minus is plus. So plus 49b square plus minus minus is again plus c square. Plus minus is minus. First put the sign. 2 3s are 6, 7 6 are 42. It with ab. Minus minus is plus, plus plus is plus. So I am getting here 7 2s are 14 cb or bc. Plus minus is minus. Fine. 2 3s are 6 AC. So this is my final answer for this. For these factors, these are basically factors of this polynomial. These identities help us to find the factors. If we have a polynomial and if we have factors, we can get the polynomial from these identities. Let's see the next question. So this is my next question. Here we have to factorize this polynomial. So if we are having polynomial, we have to find factors, and if we are having factors, by making use of identities, we can directly find the polynomial. So we can easily say that this is similar to this identity. I am taking capital XYZ. Why? Because we are having small xyz in the actual polynomial. This is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. This was the identity. So on comparing what I am having, actually this is 2x square. So I can take as capital X. A capital X can be written as root 2x. If I have to make whole square of this, it will become root 2. X square is already there, so root 2x. Why? Because 2 can be written as root 2 into root 2. This we all know. So 2 can be written root 2 whole square. That's why I have written x is equals to root 2x. Y. Y is equals to, this is simply small y, so capital Y is equals to y. Now z square. From here I am getting capital Z is equals to, so capital Z square actually is equals to 8z square. So if I have to make whole square of this, let's see, 8 can be written as 2 into 4. Yes, 2 4 is 8. 2 into, I can write this 4 as 2 square. This 2 can be written as root 2. So this is 2, which can written as this in a sorted way. So 8 can be written as 2 root 2 whole square. So to make it a whole square, this is already in a whole square. So I can compare z as 2 root 2 small z. Fine. So these are the values. Now let's see what we are having in actual polynomial. So in the first term and in the last term, not in the first, from these last 3 terms, in this term and in this term we are having minus, and in this term we are having plus in front. So we can easily say that y and z are involving in this term. So we are having plus here, and y and x are involving, we are having minus. X and z are involving, we are having minus. So clearly x will be of minus. If my x is minus, I will get this as minus in this term, and x again my minus. So let's try whether we have written this, let's check whether we have written this correct or not. So this can be written as, here I am putting the values on the right hand side. This can be written as minus 2 root 2 x whole square minus root 2 x whole square plus y square plus 2 root 2 z whole square. So yes, I will get these first three terms from here after solving. Next term is plus 2xy plus 2, this is my x, this is my y. So I'll get minus 2 root 2 xy. Fine. Second term is plus 2yz plus 2, this is my y, this is my z, 2 root 2 z. So after solving, I'm getting 4 root 2 yz. Yes, it's okay now. Next is plus 2zx plus 2, what is z? 2 root 2 small z, and this x, this is minus root 2x. So after solving, we will get 2 2, and this is making 2 again, minus 8zx. This will make, yes, it is correct again. So this expression is giving us this expression just by putting these value in this identity. So I can write, this is my x, this is my y, this is my z, this we have y plus z. So this is my x, capital X, plus capital Y plus capital Z. So this will be equals to this side. So these are the two factors, because this is whole square, so we will get such two factors, which is the answer for this polynomial. This is how we have to make use of this identity to factorize such polynomial, just by looking at the polynomial and get the similar identity and make it equals to the left hand side to get the factors. So these were few questions from the exercise. Let's see these identities, results for these identities. Now we have the identities that have degree 3. In the first 5 identities we were having degree 2, and in these 3 identities we are having degree 3. So expansion of this is, you have to learn it directly. X cube plus y cube plus 3xy x plus y. Cube of first term, cube of second term plus 3 times xy. Again this bracket you will repeat here. So this can be further written as x cube plus y cube. When we will solve this bracket, we'll get 3x square y plus 3x y square. X minus y whole cube, expansion is x cube minus y cube minus 3xy, and in bracket x minus y. So in the first identity we were having plus, and in the second identity we are having minus. So on solving, this is the second way to write, minus 3x square y minus minus is plus 3x y square. Again these are two ways to write this identity. So this can be written as, this is x cube plus y cube plus z cube minus 3xy. See, this can be written as expansion for this is equals to x plus y plus z in one bracket, then x square plus y square plus z square minus multiplication of first two terms from here, first two terms minus yz minus zx. These are the last three identities according to the book. Let's solve few questions related to these identities. So the question is asking us to expand 102 whole cube. 102 whole cube can be written as 100 plus 2 whole cube. So we know the identity, that was x plus y whole cube. This is equals to x cube plus y cube plus 3xy in brackets x plus y. Fine. So this is similar to x plus y whole cube. So here my x is 100 and y is 2. I'll just put the values here. So it's 100 cube plus 2 cube plus 3 into 100 into 2 to 3xy in bracket. I will write 100 plus 2. So this is cube, means these will be the number of zeros. This into this 3 times. 2 cube is 8. This is my 3 2s are 6, 600 here with 100 plus 2. So this is again I have to write plus 8. I'll now open this bracket, so I'll get 60,000 plus 1200. So we can sum up all these four figures to get our answer, and you will get your answer in the next step. 998 whole cube I have to expand. I can write this as 1000 minus 2 whole cube. So we know the identity for minus, x minus y cube. I have just told you, just by putting the values, x is here 1000 and y is here 2. Just by putting the values in this way, you can get your answer. So such questions in which we have to expand without actually cubing the values or without multiplication, we will make use of identities. Let's see one more question. So we all know that we have seen identities that are similar to this expression. So I can write this as all are of minus and last one is of plus. So I will make use of x minus y whole cube. So x cube minus y cube minus 3x square y plus 3xy square. This was the second identity. So I can write this expression as, to make it whole cube. So I can write this as 4a whole cube. Fine. This 27 can be written as the cube of 3. So 3b whole cube minus. Now let's see whether I am getting this term by putting these values here. So minus 3 into x square. This is my x. X square with y plus 3. What is my x? 4a. And y square. This is my y square I have to do. Let's see whether this is making similar to this or not. So yes, 16 into 9, 144 a square b, and this is my 27 into 4. Yes, 108 a b square I am getting. So this expression is okay now. So from here I am getting my x is equals to 4a on comparing, and y is equals to 3b. Now I will put these values on the left hand side. This will be equals to 4a minus 3b whole cube. So this is the answer. These are the three factors. This can be written like this as well. 3 times we can write the same factor. Why? Because we are having cube of this factor. This. So from here I am getting x is equals to 4a, y is equals to 3b. So this was the expression similar to the right hand side. So we will write left hand side from these values. So these will give us the factors. Let's see for a few more questions. So this is again a same question. This is asking us to factorize. From here this is plus minus minus plus. So this expression is somewhere similar to this identity. Again I am writing minus 3x square y plus 3xy square. Please don't get panic by just seeing the question. It's very simple. Again, that's why I'm doing this for you all. So from here this expression can be written as, this is p square. So this is p cube. So I can write this as whole cube by just writing 27 as 3p whole cube. Fine. This expression, this number can be written as 216 is whole cube of 6. So I can write this as 1 by 6 whole cube. 1 cube is 1, 6 cube is 216. Now this is my x, this is my y. Just put the value here, minus 3x square, 3p square into this y plus 3 times this x, 3p, and this y, 1 by 6 whole square. Now let's see whether these are making these terms or not. Just by cancelling 3 2s, or I can directly write 3x square. Fine. So let me write this for you. This can be written as 3p whole cube minus 1 by 6 whole cube. If I expand this, this can be written as 3p into 3p. Here in bracket I am having 1 by 6. So 3 2s are 6. I am getting 9p square by 2. 9 by 2 p square. Yes, so this is okay. And again here I am getting plus 3p. This you can do in rough work. This step you can do in rough work. So 3 2s are 6. 3 2s are 6, 1 by 4p. Yes, so this step is okay. We have written all these steps correctly. So here on comparing, x is equals to 3p, y is equals to 1 by 6 I am getting. So what is the left hand side? X minus y whole cube. So these are 3 factors of this given polynomial. Let's see further. So this is the question it's asking us to factorize. Recently we have seen an identity x cube plus y cube plus z cube minus 3xyz. The last identity I have written, this was the result, x plus y plus z, then x square plus y square plus z square minus xy minus yz minus zx. So this was the identity that is looking similar to, left hand side is looking similar to this expression. So from here I can write this as, to make it whole cube, 3x whole cube, fine, y cube as it is, z cube as it is. Now this minus 3xyz, minus 3xyz will give me 3 is a 9, minus 9xyz, fine. So I can write this as minus 3 times x, y, z. So we have taken correct values. To write its right hand side, I will just put these values here. So this question was in xyz, I have taken identity in xyz. We can choose different alphabets. Let me take this capital X, capital Y and capital Z. Capital X, capital Y, capital Z. So here I am getting capital X plus capital Y plus capital Z. Here also try to write the identity in different alphabets. Minus xy minus yz minus zxy, because we have to compare the values. So from after comparing, I am getting x is equals to 3x. Okay, capital Y is equals to small y, capital Z is equals to small z. Fine. So just put these values x, y, z for this capital X, capital Y, capital Z here. So I am getting 3x plus y plus small z and x square. 3x square will give me 9x square plus y square plus z square as it is minus xy. Minus xy means minus 3xy. Minus yz means simply yz. Minus zx means minus 3zx or xz. So this is my answer for this expression. Why? Because this was similar to this identity. We have just written this full identity, and on comparing we are having these values, and make use of these values to get your answer just by putting these values in the identity. So these were few questions from the last exercise of this chapter, polynomial. So we have done with this chapter. Rest of the questions that I am left with, I'll try to make a worksheet related to this chapter. I'll solve that questions in that video. Till then, take care, study hard, hit like if you like, subscribe for more. Thank you for watching. Have a good day.